just a little friend. We'll just meet him very briefly. We'll not dig into, try to understand the nature of the back of his mind very much, and the friend is called the log normal distribution. The log normal distribution has a pretty nasty looking density function. And the mean and variances also suddenly looks a bit not as friendly as before. Actually, mathematically, and also as I'm showing you, this is a density function that can be used for only positively valued systems or phenomena. For instance, exchange rates or stock rates, concentrations in the blood of something. We cannot have negative concentrations of anything in our blood. That is a very commonly used distribution. The reason why it's called the log normal is in a way seen here. It's because it's linked to the normal in this way, such that something which is log normally distributed, that is a positive thing, it is only correct to say that it is log normally distributed if it has the property that when I log transform it, it becomes a normal distribution. This is something which is used in practical statistic data analysis a lot, actually. That if you have some data that looks, when you start looking at data, now I jump to the stats side of it, we'll get back to that later. If you have data like this, that has this right-skewed shape, and these data are very, very commonly occurring out there, such phenomenon occurs a lot, then I can change the scale of my analysis. For instance, by not looking at my raw data, but by looking at my log transformed data. So I just apply the log function to my column in my Excel sheet. So I have log heights or log concentrations or log exchange rates. Actually, in econometric modeling of such things, that is the most commonly way to model things, to actually use a log normal approach rather than a normal approach, due to the positiveness of such phenomena in econometric. But it goes in biology and things like that also. So the way we can work with it is, if we are told that something is log normally distributed, yeah, we either jump to R, or we change it to a normal distribution by this little trick here. You should try it. That's as far as I would introduce this little friend. You'll have the chance to play around with him out there later. So we jump, Gandalf, to this little overall.